Welcome to the Intersecting Us podcast, where math and life intersect.
In today's podcast, Dave and Brian consider the infinite side of math and eternal side of life.
Back to what you were talking about with eternity, and why did I choose this first video on the sunlight? You know, we're talking kind of like high and mighty kind of ideas, but I'm going to kind of bring this back to home a little bit for myself. And what do I find joy in? What has spoken to me? And so this first video is about just a little story that has brought me joy. Now, it may not bring you joy, but as we talk about things that are disconnected, I enjoy seeing things come together and being connected. When we think about each day, there seems to be a lot of randomness that goes on. Think about the weather, right? The weather can be up and down, and we always like make fun how the weather people never get it right. Sometimes that can be a little jarring. But if we think about like how much sunlight we see, well, we know as summer approaches that we're going to see more sun. And as we approach winter, then we're going to see less sun. And each day there's a sunrise and a sunset. But it kind of seems like this random point out there when we think about, well, how much sunlight will we get each day? It's going to kind of go up and down from the seasons, but there doesn't seem to be any flow to it. There doesn't seem to be anything that connects those dots. And then a couple of years ago, I happened to stumble into the math behind that. And lo and behold, we find out that there is a pattern to it. There is something that connects those dots. There's a curve that is at play behind the scenes that dictates how much sunlight we see each day. And it's very predictable. And it's a well-known curve. It's called the sine curve. I just got a lot of joy out of that. I remember first reading about that. And all of a sudden, I kind of thought, like, you know, every day when I wake up, I may not know what's going to happen. There may be a lot of random noise going on in my day, but there's this pattern that I can think about to start my day that's kind of built into nature that has a flow to it. And I know what that flow will be tomorrow, and it's going to repeat every year. It's not like anything that's going to solve the world's problems. But what it is important to me was it just brought joy to me. And so that's why I talk about this one example in our first video, because it was a personal experience of mine that I enjoyed learning about this connection in math.
Yeah, and I think that type of video is important to think about because it gets us started on something that's very natural. It's a pattern that has developed over time in our physical world that we can measure, but yet it still starts to think, how long is that going to last? Is that going to last a long time? Is it going to last? Because you can do the math, as they say, and find out that there are, with entropy and things could change, and obviously sun's getting bigger and all, is it going to go on forever? Yeah, it'll go on forever as far as our way of measuring it, at least the time period. Most of us probably don't need to worry about the sun getting too big for us to live. But it does bring us back to where are we going to be, depending on how old you are, 150 years from now, let's go. That should clear everybody out, unless we find some really big innovations. And that's what the first video questions are from kind of the philosophical side. It's taking what we see in math and something that has a pattern there, and then talking about the patterns of our everyday life and how does our life intersect with the world and our own experience past this existence. Does it stop? Does it go on? Those are questions we're going to probe.
Right. We've been given this pattern that is a continuous flow. And if we think about eternity, that has a flow to it. It shows a continuous process, and it's easier to think that there is an eternal component time when we see that there is a continuous flow in our day-to-day living. We see it in the seasons, winter, summer, spring, fall. That allows us to see a flow to the year, but what this is kind of like a flow to the day. We know the sun comes up every day, so we've got that flow going. But we didn't necessarily know that there's a flow to how much of the sun we see each day. And so that's kind of another example of a pattern that we can start each day out with, just as a friendly reminder that there's continuity in this world. There's dots being connected, There's just beautiful math that is happening when we take the time to look at it.
Well, the perspective matters. I would assume you don't have to go too far on the globe, a different point of perspective, and then your sunrise, sunsets, it's still a sine curve, but it's different. The timing is different, right, when it happens. And so perspective is so big here. For instance, some ancient texts will say that the sun rises and the sun sets. And then people will say, oh, those texts, they weren't scientific. They didn't know what was going on because they're saying that the sun actually is moving. We know that it's the rotation of the earth and it just happens to be 24 hours. Well, we know that, but yet when I got up this morning, I looked at the weather app and it said sunrise. And this is a very, very scientific weather app. It gives me all kinds of mathematical information and weather information. But do these people not know? The sun, it says sunrise. It's like, well, no, it's Earth rotates, so I see sun. I guess my point here is that the way we look at things and the way we use language sometimes is from the perspective of the person that we're trying to reach.
Right.
So maybe we shouldn't get so mad at maybe these ancient people knew more than we thought and they just put sunrise because we still do.
Right.
But it's that language idea. And that's the thing that math does, I think, for us, especially when we talk about infinity and eternity. It helps us speak that language. And that's what these first two videos are about. Well, the whole eternity series is that way. Let's let math speak the infinite language, and it does it so eloquently. And you're going to give us some really good ways. The first one you said is going to be the sine curve of sunrise, sunset. But now we can get our mind around at least a little bit. And you don't have to be a mathematician to do that. I mean, you can look up sunrise, sunset on the internet like I did and understand it. But you're going to give us some more ways of understanding it and some more beautiful ways of understanding it. But yet then that allows us to go over, okay, now I kind of understand. I understand this. Math's given me some language to understand infinity or eternity. Now I can talk about our lives because kind of back to your grandkids again. It's like, well, how old are you? Well, I'm 59. And then you're 59 plus one, and then you're going to be 60. But eventually, I don't know if infinity works there, as far as our mortality. And that's the age-old question. And then the beauty that comes from it, I don't know how many people around the world, maybe today, maybe woke up because they wanted to see the sunrise. Now, did they do that because they thought of the sine curve stuff? Probably not. Why do most people get up to see the sunrise? Because it's pretty. Yeah, because it's beautiful. Well, there you go again. But I think what we do is we tend to think either or. I either look at this from an aesthetic point and think, well, this is beautiful, or I think about the symmetry of the earth and the way everything is designed to work in such a cool way, and we can measure it. And isn't Einstein that said something about the most miraculous thing about the universe is that it's definable, it's measurable. He had an awe there. It was kind of an aha moment for him that we can actually measure this stuff and we can predict things and all that kind of stuff. But we want to get into stuff where you do this with math. Things that we wouldn't you did that in an earlier podcast, the idea of looking at odd numbers. That I didn't think about it that way. And that's another thing we're trying to do. Maybe have you look at math, certainly, and life from a different perspective, to see it through a different lens, to maybe appreciate it more, and to think about things that maybe matter more and not less. Yeah, you could probably, if you're a listener or Dave anyway, and it's like, yeah, this dude can go on this for infinity. It's relating to each other. And then I hope we can get some people to interact because we're going to get some ideas that we didn't think of. You might get some math things that you didn't think of when we get some comments on the videos. We encourage you to go to those, to just intersectingus.com, to just engage and have some. I hesitate to use the word fun because sometimes that seems like it's frivolous, and that's not what we're talking about here. Joy is maybe a better word. Maybe find some joy. Maybe connect with some people that you wouldn't have connected with. It doesn't have to just be us. So when you look at the eternity, you're coming back to the math part of it. You've got those different things when you're looking at this first video with the sine curve, and maybe you could just talk a little bit about the trigonometry and the calculus and how those kind of
Well, I'm going to put you on the spot here, Brian.
Oh.
Because I know you're good in math. I mean, you got a math degree, is that right?
Yeah.
Advanced math degree. So,
At least one.
Yep. And so if I bring up the concept of a sine, S-I-N-E, or S-I-N, however you want to write it, there's no right answer here. What do you think about?
You said there's no right answer, so I think of waves.
Dave illustrates the difference between the sine curve and the sine function by diving into the unit circle.
So we have sine waves and a sine function. And what is the difference? And are these two connected? For starters, the sine function is a key in your calculator. So anything that is enshrined as a calculator key is important. So let's refresh our high school trig, and we will define what the sine function does. First, the input into the sine function is an angle measurement. It could be degrees, like 30 degrees, or it could be radians. The radian measurement that equals 30 degrees is pi divided by 6. So let's build a triangle with 30 degrees. Okay, there are 360 degrees in a full circle, so 30 degrees is 1/12 of that. So that makes us think of a clock. So imagine a line segment from 9 o'clock to, let's say, 3 o'clock. It is just a flat line through the center of the clock, and we will call this the horizontal line. Now, imagine a long hand of the clock that rotates around where the length of the long hand is 1. Our entire experiment will be identifying the distance from the end of the long hand straight to the horizontal line from 3 to 9. So let's assume the long hand points to 2. We got a 30-degree angle with the long hand and the horizontal pointing to 3. In other words, the angle here is 1/12 of the full clock, so it is 30 degrees. Again, our goal is identifying the distance from the long hand to the horizontal. And the distance is the length of the segment that is perpendicular to the horizontal. And this line segment, perpendicular to the horizontal, is what measures the height of the triangle and is the distance that we care about. Notice the long hand pointing to 2 is the longest, so it is the hypotenuse, and we created a right angle from the height of the triangle since it is perpendicular to the horizontal. In short, we have a right triangle, and we can dig into the weeds of the sine function. The sine of an angle is the ratio of the length of the side that is opposite that angle to the length of the longest side, which is the hypotenuse. And notice the length of our hypotenuse is the length of the long hand pointing to 2, which is 1. And since the hypotenuse is 1, then the sine of the angle is just the length of the opposite side, which is the height of the triangle. And notice, this is just a clever way to simplify our math. So what is the sine of 30 degrees? Well, if you punch that into your calculator, you get 1/2. And this means the height of the triangle is 1/2. Okay, well, first, that is an interesting relationship that you may not have noticed on a clock. If you define the long hand as unit 1 and is pointing directly at 2, then the distance from the end of the hand straight down to the horizontal is 1/2, where 1/2 in this example is simply 1/2 the length of the long hand. Okay, that's our sine function. How do we get our sine curve? Well, first we must convert our 30-degree angle to a radian measure, which is pi over 6. So in simple terms, think of the input as pi over 6, the radian measure, and the output is the height of our triangle. And in this case, it is 1/2. That is our sine function using the radian degrees. And we get the sine curve simply by considering all angles in a complete circle. So let's start at the beginning where the long hand points to 3. Since the long hand overlaps our horizontal line, the angle is 0. The sine is also 0 since the height is 0. And notice the hypotenuse is always 1 since that is always the long hand on the clock, that is the radius of the circle. Then if we go counterclockwise from 3 o'clock, we get all the other points. We already got 2 o'clock, and if we jump to 12 o'clock, the radian measure of the angle is pi over 2, and the sine of the angle is always the distance from the point on that circle to the center of the clock. And the distance from the center to 12 is the same as the distance from the center to 2, which is 1. So the sine of pi over 2 is 1. Okay, good. Now, let's consider the case where the long hand is pointing to 10. And the angle from 3 o'clock to 10 o'clock is 5 times the angle from 3 o'clock to 2 o'clock going counterclockwise. So the radian measure is 5 pi over 6. But again, we get the height by taking the distance from 10 straight down to the horizontal line. And notice the distance from 10 to this line is the same as the distance from 2 to this line. So the sine of 5 times pi over 6 is also 1/2. Okay, do you see the symmetry that's at play? The height of our triangle going from 12 to 9 is symmetrical to the height going from 12 to 3. And then once we get the triangles identified on the top half of the clock, the triangles on the bottom half are symmetrical, but now the height is the opposite direction. So these are negative results. But you should see the symmetry that's emerging every 1/4 of a turn around the clock. Well, that's wonderful. So now it is only a small step to fast forward this into a movie. If you think about the long hand of the clock starting at 3 and rotating counterclockwise once around, then the range of our input starts at 0 and then goes full circle. And the radian measure for a full turn is 2 times pi. So the input are all the real numbers from 0 to 2 pi. And the output is the distance from the long hand straight to the horizontal, either down or up. The height is 0 at the beginning, reaches the maximum height 1 at 1/4 turn, which is 12, returns to 0 after 1/2 a turn at 9, then becomes -1 at 3/4 of a turn at 6, and returns to 0 when we arrive back at 3. And notice the connection between the sine function, the picture, and the sine curve, the movie. And the connection is both are triangles within a clock, which of course is a circle. And this is cool because when we think of the sine function from trig, it is just about straight things. But that is a snapshot perspective. But if we kick it into action by rotating it around a circle, we create a movie, and in that movie, we create the sine curve. And if you like to take static things and kick them into motion, you really need to study calculus because that is what calculus does. And that's the beauty of what calculus is about.
Brian discusses the importance of different perspectives and how they lead to new insights and conclusions.
Well, like you said, it's a different in perspective. I don't know if it's thinking better, but it's thinking deeper, maybe, or opening up your perspective to looking at life as a 2-dimensional space versus a 3-dimensional, kind of what that's doing. But then you add motion to it. Calculus, the different rates of change, it's all about motion, is trying to quantify that depending on if you're differential or integral. But the idea of that, it's a way of thinking. And then again, you start going back into life. It just fits so well because the perspective of looking at where your life is now. But don't we all, I'm not really talking about eternity. I'm just talking about motion here, kind of the analogy you have. Don't we think about the future? I mean, I suppose whoever's listening, hopefully you're thinking about what we're talking about, but you might be thinking, what am I doing the rest of the day? What am I going to do tomorrow? What am I going to do in a year? What am I going to do in 10 years? That's kind of life in motion. How much control do I have over that? In math, we don't have control. We don't really create what math gives us. We discover it, I think. In math, we can create ways to discover it. I think that's maybe a put it. In life, we do have a level of being able to create our own future, as they say. But it is based on a set of contingencies that we have to deal with. If I want to fly somewhere today, I could, but I'd have to have an airplane. I couldn't just flap my arms. You have contingencies about what we're going to do. And as we look at life in the future, I do think there have been philosophers who've talked about, and I think it fits pretty well with what you're talking about, from going from trigonometry to calculus perspective of kind of 2-dimension or straight edges to curved and 3 dimensions moving and all that kind of stuff. I do think philosophers have said that the person who can't think about the future will really stifle their present. Mm-hmm. Because your mind is just it's not focused on where you're going. It's just focused mm-hmm. on where you are.
Right.
And I think that's a little bit about what we're trying to get into with this too. And that's why this first math video is so cool in so many ways, is because it captures that sine curve from the sun rising and setting, and something that is very elegant and can be pretty, like we said before, but it's known, but it also interestingly makes us think about the future, because you might change what you're going to do based on when that sun goes down, because it gets dark. Yeah. And so I think the way this intersects is pretty interesting. And I do think one of the things that we're trying to do too in the videos and the interaction and the podcasts and the website is to try to get that different perspective of different people. Mm-hmm. Because, you think about when you've talked about even the example you gave about the unit circle and all that, I might look at that and get something completely different that matters to me, and you might want to hear about it. Mm-hmm. And because, like you said, what did I think about when you said sine? Well, I thought about like that, I don't know what they call it, the little oscilloscope or something that has a little green sine thing. It's sound waves kind of have a sine, mm-hmm. The Doppler thing and all that. That's what I thought about. That was my perspective. And then you started with something that, it didn't seem like it was, but when you got done, it's like it was, because you end up getting the sine curve that mm-hmm. we use when motion comes. So I think hopefully people are seeing, Dave and I have known each other for a long time. One of the beautiful things that we've been able to do is when we start talking, we often come to the same conclusion about a lot of things, but we come to it from different perspectives mm-hmm. and different directions. And that's kind of what we're trying to do. Well, with the whole project of Intersecting Us, but certainly with this set of videos, the eternity and the sine curve. So to kind of use your own words here, maybe talk about this a little bit as we finish up here, going from what we would call like a snapshot, which the analogy for life would be what's going on right now, mm-hmm. to a movie, which would maybe looking at what's gone on in my past and what goes on in the future. Is that kind of help that sine curve, sunset, sunrise thing kind of has that snapshot movie type of idea in it, doesn't it?
Dave shares how math comes alive by reframing static things as things in motion.
Okay, Brian, let's return to our clock analogy. Now, let's let 3 o'clock represent the first day of spring, 12 o'clock the first day of summer, 9 o'clock the first day of autumn, and then 6 o'clock the first day of winter. So how can we use the clock to predict how much sunlight we get each day? And how can we create this movie? Remember, the output of the sine function is the distance from the long hand to the horizontal. So at 3 o'clock, the distance is 0. Now, I will simplify the problem a bit, but you will get the idea. However, don't think it will predict a perfect model. So let's take this sine result and add 12 to it. And we're adding 12 because the first day of the fall may be about 12 hours of sunlight. And now if we jump to the first day of summer, which is 12 o'clock, the sine result is 1. And in our simple example, we will simply add 1 to 12 and say that there are 13 hours of sunlight on the first day of summer. Again, this is just a simple example. If this was an exact model, then we could get the number of hours of sunlight 1 month after the first day of spring. This is because 1 month after the first day of spring is 1/3 of the time from the first day of spring to the first day of summer, and 1/3 of the way from 3 to 12 counterclockwise is 3 to 2. Okay, remember we know the sine of this angle is 1/2. And that means that even though we are only 1/3 of the way from spring to summer, we are halfway of the change in amount of sunlight to go from 12 to 12.5. And since we go from 12.5 to 13 to get to summer, that means that the next 2 months, we only add 1/2 an hour. And that tells us that we get half of our increase in sunlight the first month of spring, and we get the other half of the increase the last 2 months of spring. So think about whether that is consistent with how you perceive sunlight to change from spring to summer. Okay, another question I want you to think about is, why does the sine curve appear? And if we think of the sine function from trig, it is about straight things, straight lines, triangles, etc. But the sine curve is about creating an infinite number of those triangles as we travel around a circle. So the sine curve is about a circle. And notice the shapes that we have play in our sunrise. We have the Earth, which is a sphere. We have the Earth rotating in a circle. We have the Earth revolving around the sun in an elliptical orbit that is nearly circular. And then we have the sun, which is also a circle. So with all these circles involved, is it not a surprise that we find the sine curve showing up? So not only was it cool to see how we pivoted from a static sine function to a fluid sine curve by considering a point moving along a circle, but it also opens the door to see where the sine curve may show up in life. And it shows up where circles are involved. And this is where math becomes super cool. And we see it in something so simple as a clock. We can take a snapshot and see where the second hand is at on the clock at a given moment. But we get the movie by letting time fly and imagining the hand moving around the clock, and then thinking about how things change with movement. And calculus is that wonderful idea of math that allows us to make sense of curved things and make sense of motion.
Brian shares that while it's interesting to read about other people's perspectives, it's ultimately your own perspective that matters.
Yeah, and I do think, and again, you just see how that intersects so much with life. I think a lot of what we'll talk about over time is this perspective idea. And that is, because in our lives, we can read about, Leibniz and Einstein and Euler, and you can listen to podcasts and get other people's perspective. But ultimately, it's your perspective that is the one that you interact with, And so even though it's neat to use your analogy of movie, it's neat to watch a movie or read a story. It only gets meaning when it somehow intersects. You can have joy in it without, but it gets deeper meaning, I guess I could say, when it intersects with your life and you see somehow how that can affect your life in some ways. And I think that's what's so changing perspective and really looking at things in different ways is what math does. And that's what our video series is trying to show everyone and even ourselves. When it crosses over into the life side, that's the thing we're trying to get a catalyst going. Let's start intersecting with each other, but intersecting with material and thought processes to maybe get each person to think about things deeper than they may have if they didn't interact with material and think about sunrises and sunsets and sine curves and all those types of things. Because ultimately, we want to, I guess, I'm trying to think what our goal is. I guess our goal is to help people think more deeply about things that can give them some joy, I think, is probably still the best word to use. So not just entertainment, which I'm hoping you're entertained, but really joy. Real joy to me is something that's real. It's not artificial.
Exactly.
It's emotional reaction to something that really, really makes you happy.
Dave finishes with a tip on how to have your math come alive.
Brian, that reminds me, and I hadn't thought about this till just now, but earlier this spring, I got a chance to talk to a group of college students who attended a conference at Drake. And then many of these seniors were ready to graduate in actual science. I shared a process of transitioning from academic to the business world. My goal was just to highlight how much of their perspective will change the next few years. So far, they mainly have learned about actual science from a theoretical perspective. It was only hypothetical problems. There was not real money on the table. But I told them that soon their problems will be real with a lot of zeros after the one. And when that happens, their actual knowledge will take on a new dimension. It's like now their math is in 2 dimensions because it comes from paper. But soon their problems will be real life problems, ones from 3 dimensions, and that transition will have a major impact on how they view math. So what's at the heart of this is that soon you'll be responsible for the answers, but you will also be responsible for asking the right questions. And we don't have to be dealing with millions of dollars for math to come alive. For me, math comes alive into that third dimension when I start asking questions. It isn't so much about the answers, but it's about wondering, what if? So if we can inspire you to ask more questions, to wonder more, to be more curious, then I think your math will become more real, and then we've probably accomplished something.
Yeah, that's what Intersecting Us is about. It's intersecting people and concepts in different ways and trying to find maybe some deeper meaning, some deeper thought processes, using math a lot, but also crossing it over into life.
This has been the Intersecting Us podcast. To further engage with Intersecting Us, go to intersectingus.com.